Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in. Okay, so what changes about particles when substances change state? So really you would need to talk about two things here. The first one is their arrangement. So for example, in a solid, your particles will be in a regular arrangement, whereas for a liquid, they would be random or an irregular arrangement. And then also to do with the movement of these particles. So again, for example, in a solid, you talk about them vibrating about a fixed point, and then in a liquid, you would talk about them sliding over each other. And how are these changes different from chemical changes? Well, we don't have any new substances that are formed in this physical change, which is what happens when we have a change of state. And also, they're easily reversed. So again, two things for that answer there as well. Okay, let's do some predicting of states then. So predict the state of the following substance at 30 degrees. And we are given some melting points and some boiling points. So let's have a look at substance A first, and we're going to draw these diagrams, these ones where we have a line and put our temperatures on them. So I put 30 degrees on my line, and then I am going to put in my melting point and my boiling point. So there, my melting point is below that 30 degrees, and my boiling point is above it. So what this is really telling me is that my substance has melted because 30 degrees is above 10 degrees, but it is not yet boiled, which means it must be a liquid. Okay, now let's have a go for B here. So I put my 30 degrees in again. This time my melting point and my boiling point are both below that 30 degrees. So it's gone above the melting point, it must be at least a liquid, but it's also gone above the boiling point, which means that it must be a gas. And then substance C here, put my 30 degrees in, put my -10 and my 36. Again, it's in between those two, melting point and boiling point, so it must be a liquid. We haven't gone through what would it be if it were a solid, and in order for it to be a solid, it has to be below that melting point. So it would have both the melting point and boiling point above the temperature. Water is heated until it boils. The temperature of the water is measured as this occurs, and then the temperature is plotted against time, and explain the shape of the graph. So let's add some information to this graph here. So from A to B, we have it in a liquid, and then B to C, it's boiling, so it's a mixture between a liquid and a gas, and then from C to D is when it is a gas. So between A and B, what you can see is the temperature is increasing with time, and your temperature of your particles is to do with how quickly they are moving, because your temperature means that if you have getting a higher and higher temperature, your particles are moving faster and faster, and their kinetic energy is increasing. Now, between B and C, you have your temperature remaining the same with time. And that's because your particles now are actually becoming more spread out. They're still going to be randomly arranged between boiling water, between it being a liquid and a gas, but the spaces between them are getting larger. So the energy that you are adding there when you're heating your substance, in this case water, is being used to overcome those forces of attraction between the particles that were keeping them close together. Temperature does not increase. That is the important thing to remember here. When you're changing state, the temperature of your substance does not change. And then C to D, again, now they are more spread out, these particles, because we are in a gas. But again, as the temperature increases, what that means is these particles are moving around much quicker. Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not? Here's some tips and tricks for this
section. First is always refer to the arrangement of movement of particles when you are describing state changes. So make sure you mention those two different things. Structure and bonding knowledge does link to this topic. So the stronger the attraction between those particles, then you have this higher melting and higher boiling point as well. Be specific with your language when you're talking about these questions. Water vapor doesn't just turn into water. Water vapor condenses to form water. Okay, so make sure you're using those key words.